So this part we're discussing in the last lecture. Okay, so this part is actually I H cross. However, they can also be some I into some omega that can be a Hermitian operator. Agreed? It can be some omega that can be a Hermitian operator. So as a result of which, let me do this part again. What can happen is that there can be a 1 by 4. The I will come outside and there will be a psi and there will be this omega left here and there will be a psi square. In this case, the omega is fortunately H cross, but in other cases, for example, in mathematical cases, omega can be a Hermitian operator. That's why the I comes outside, or else anybody would think, why don't we write IH cross here and square it? No, you can't do that. Now, one more thing. We have forgot to put the mod here. Agreed? So these were all the modulus. Even here we'll put a modulus. So mod of all this. Agreed? So what do we get? So we have actually, so we can write, so instead of this part, what we can do is, so we can write here I taken outside. Okay, and what is left here? An omega operator left here. So what will be the final answer? The final answer will be as follows after removing the mod. So if we remove the mod, so there is no use of this I again. So we'll be having the first term as it is, which is 1/4 of the operator that we have here. Okay, so this part will remain as it is, and then on the second part we can have H cross square divided by 4. Great, because in this case what will happen is we have an I, will have a 4, so we have an I, we have a 4, and then we'll have H cross square. Okay, and then we'll have this probability, because we know that psi bar psi cat square is nothing but probability, and we know that probability is always 1. So indirectly this part is always positive. This part is always positive. So what we can say, so we can easily say that del x square, okay, and del p square is greater than h cross square by 4. Okay, this can be easily said because the first term is actually positive. So what do we get? So we get del x del p as greater than equals to h cross by 2. This is the famous Heisenberg equation, Heisenberg uncertainty principle. Agreed? Now this can turn into an equality. What I mean to say is I can write del x and del p, so product of two uncertainty, can be equal to h cross by 2. Okay, only if the condition is satisfied, if this is equals to 0. Okay, so when this is equals to 0, I can have an equality in the equation. So this is an inequality, Heisenberg uncertainty principle. This is an inequality, and if you want to convert it into an equality, then you need to have this first term as 0. Agreed? So why we are doing this? The reason is we can find the minimum wave packet psi which at least satisfies this condition. So this will be our next target. Our next target is we need to find a psi which will at least satisfy the minimum Heisenberg uncertainty principle, which is del x del p. So uncertainty in x and p is equals to h cross by 2. But there is a small catch here. Many would argue that there is a tilde here. Okay, so there is a tilde. So the question will be, if there is a tilde here. Um, oh, no, not here. Um, yeah. So yeah, it's okay, no problem. So many would argue that the uncertainty that we used. Okay. So for example, the uncertainty that the this part, this part. So we wrote this part as I h cross, and many would argue this is in tilde. How can you write this as I h cross? Because we know that x and p should give us I h cross, not x tilde and p tilde. But the answer is even x tilde and p tilde can give us, because you know that x tilde is x minus um, expectation value of x. So you can choose a particular wave function for which this expectation value of x can be 0. We have already done same thing in our previous lecture. A special choice of psi whose expectation value of x is centered at origin. This can be done. So when this is done, we can easily put I h cross in this part. X tilde and p tilde can easily become x and p commutative relation. Agreed? So our next target, so what we have done is we have fulfilled our target. So what we did, in summary, what we did is that we started assuming that the x and p commutative relation is satisfied. Okay, so we started with this, and by using Schwarz inequality condition, we reached the uncertainty principle. So this condition of commutator has the same power as the uncertainty condition or the uncertainty equation. Both are the same. Agreed? So either you use Heisenberg uncertainty equation as del x del p greater than h cross by 2, or you use the commutator. It's the same thing. Okay. So what is our next target? Our next target will be to find the minimum wave function which satisfies the minimum Heisenberg uncertainty principle, where del x del p is h cross by 2. Okay, so that will be our next lecture.